You know that feeling when you're in a debate and you just know you're right, but you can't quite put your finger on why? It is so frustrating. Well, today we're going to fix that. We're diving into the rules of inference. Think of these as the secret blueprints for building a totally airtight argument. So let's get into it.
All right, so let's just get right to it with a question I think we've all asked ourselves at some point. How do you actually win an argument? I mean, is it just about who can talk the loudest or maybe having the perfect witty comeback? Or is there something deeper going on?
Well, here's the thing. The real secret isn't really about winning at all. It's about being correct. The absolute best way to make your case is to build an argument that's just logically solid, right from the very beginning. And that's exactly what we're going to do today. I'm going to show you the toolkit you need to make it happen. Okay, so before we can start building, we've got to know our materials, right? Every single logical argument, doesn't matter if it's a super simple deduction or some complex scientific proof, they're all built from the same basic parts.
So, the most basic building block of all is something called a statement. Now, a statement isn't a question, it's not a command, it's just a sentence that makes a claim. For example, the sky is blue. That's a statement. But is the sky blue? That's a question, not a statement. And this whole true or false thing, that is the absolute bedrock of all logic. All right, next up are premises. You can think of these as the foundation of your argument. They're your starting facts, your evidence, the stuff you're assuming to be true right from the get-go. These are the statements we all agree on just for the sake of the argument.
And that brings us to the conclusion. This is the big reveal, the new statement that you can logically figure out from your premises. See, the entire point of an argument is to prove that if your starting premises are true, then this conclusion has to be true too. No way around it. So here's the really important part. You can't just jump from your premises straight to the conclusion. It doesn't work that way. There's a process. You start with your premises, you apply what's called a rule of inference, which is basically a specific logical tool, and it's that tool that lets you build a bridge to your conclusion.
All right, time to open up that toolkit. Our first and probably the most common tool you'll ever use is called Modus Ponens. Seriously, this thing is the workhorse of deductive reasoning. It is the most straightforward, direct path you can take from point A to point B. Now, don't let the symbols here scare you. This is actually super simple, but incredibly powerful. All it's saying is, if P leads to Q, and you know for a fact that P happened, then, well, you can be 100% sure that Q happened too. Oh, and that little symbol with the 3 dots, that's just a fancy way of saying therefore. It's like a little flag that says, hey, we've reached a valid conclusion. So if you want to get technical, its formal name is the rule of detachment. And what this big logical formula here shows is that modus ponens is what's called a tautology. That's just a fancy word that means it is always true. No matter what P and Q are, this structure is logically sound. It's one of those fundamental laws of logic you can always count on. Let's make this real with a super simple example. Let's say P is it is rainy, and Q is the pool will be closed. So our first premise is, if it's rainy, then the pool will be closed. Then someone tells you the second premise. Hey, it is rainy. What's the only possible conclusion? The pool is closed. See? It's simple, it's direct, and you just can't argue with it. Okay, so if modus ponens is all about reasoning forwards, our next tool, Modus Tollens, is kind of its mirror image. It lets us reason backwards. It's more of an indirect path, kind of like being a detective and looking at the result to figure out what must have happened before.
Yeah, this structure looks a little different, but trust me, the logic is just as rock solid. Here's what it says. If P leads to Q, but you find out that Q is false, and that's what that little squiggly symbol means, not or false, then P has to be false too. It makes perfect sense, right? If the thing that was supposed to happen didn't happen, then the trigger for it couldn't have happened either. And just like its cousin Modus Ponens, Modus Tollens is also a tautology. Its logical structure is always 100% true. That makes it another one of our core foundational rules. It's the perfect tool for proving something didn't happen by showing that its necessary consequence didn't happen. Check out this example. It makes it super clear. Let's say P is it snows today, and Q is the university will close. So the rule is, if it snows, the university will close. But then you look out the window and you see the university is open for business. That's not Q. Using Modus Tollens, what can we figure out? We know for sure it did not snow today. See how that works?
Okay, so we've got a couple of basic tools in our belt now, but this is where the fun really begins. The real power move is when you start linking these simple rules together to build these long, complex, and totally solid chains of logic. And there are two key rules that help us do this. First up, hypothetical syllogism. Think of this like setting up a line of dominoes. If you know P knocks over Q and Q knocks over R, well then you know P is going to knock over R. You can just skip the middleman. Then we have disjunctive syllogism. This one's even simpler. It's just the process of elimination. If someone tells you it's either P or Q, and then you find out it's not P, well, it's got to be Q, right? Now, knowing the rules is great. But you know what's even better? Knowing when someone is breaking them. Being able to spot a broken argument, that's like a logical superpower. So let's look at a really common mistake that looks almost right, but is totally wrong. And this is where you have to pay really close attention, because the fake can look a lot like the real thing. On the left, you've got our good old friend Modus Ponens. We know that's valid. But on the right, we have a fallacy. It's called affirming the conclusion. This is where you know the final result, Q, is true, and you make the mistake of assuming that the first part, P, must have caused it. This is a classic logical trap. And here's a great example of why that's a total fallacy. The argument is, if the professor gives chocolate, you answer. Then it says, you answered. And the conclusion is, therefore, the professor gave you chocolate. But hold on a second. Is that really true? Of course not. Maybe you just knew the answer. Maybe you wanted to participate. There could be a dozen other reasons why you answered. Just because the result happened, it doesn't prove the specific cause you're assuming. All right, team, we've got the rules, we know how to spot the fakes, it's time to put it all together. Let's take on a more complex logical puzzle and see how all these tools work together to solve it. So, here are our starting facts, our hypotheses. We've got a bunch of them. Our mission, should we choose to accept it, is to use our rules of inference to see if we can legally, logically prove this conclusion. We will be home by sunset. Let's do this. Okay, let's walk through the proof together one step at a time. Step 1. We start with that first hypothesis, it is not sunny this afternoon and it is colder than yesterday. There's a simple rule called simplification that lets us just pull out the first part. So we now know for a fact it is not sunny. Got it? Okay, step 2. The next premise says we will go swimming only if it is sunny. Well, we just proved it's not sunny, so using our detective tool, Modus Tollens, we can conclude we will not go swimming. Boom. Step 3. Now we look at the next premise. If we do not go swimming, then we will have a barbecue. And guess what? We just proved we're not going swimming. So, using good old Modus Ponens, we know we will have a barbecue. We're almost there. Final step. The last premise says if we will have a barbecue, then we will be home by sunset. And since we just proved we're having a barbecue, one last Modus Ponens gives us our grand conclusion. We will be home by sunset. See? Each step was a tiny logical move, but we chained them all together to create a completely unbreakable proof.
So in the end, this stuff isn't just for a logic class or some academic paper. These are real tools for thinking clearly. You can use them every single day to test your own ideas and the arguments you hear from other people. Which kind of leaves us with one final big question to think about. Which of your own beliefs are actually built on the strongest logical foundations?